Hi everyone, in this lecture we are going to solve some more numericals that are based on entropy. This is the video part 2 based on entropy. And here is question number first. It says that a black and white TV picture element consisting of 525 lines of pictures. How many lines? It's 525 lines of pictures. And we need to assume that each line consisting of 525 picture elements. So there are 525 lines and 525 picture elements are there. And in each picture elements there are 256 brightness levels. And the pictures are repeated at the rate of 30 per second. And what we need to do is we need to calculate the average rate of information content by the TV set towards the viewer. So let's talk about the data or the information that is given to us in this question. So here is the solution, and we are given that there are 525 lines of picture. And in each line there are 525 picture elements. And each picture element consists of 256 brightness level. Which are repeated at the rate of 30 per second. So this is the data which is given to us. I am repeating this data again and again because we will use this data in solving the further steps in numerical. So what we need to find is we need to just calculate the average rate of information. Since the average rate of information is denoted by capital R, that is being given as R into h of x. And for the calculation of this capital R, we need to first determine the small r. After that we need to determine the h of x, that is nothing but our entropy. So let's calculate this small r first. So here is the calculation for small r. This small r specifies the rate at which the picture elements is transmitted by the television. So the value of this small r depends upon the three factors. First one is the line, second is the number of picture elements, and third is the rate of transmission of these picture elements. So the rate at which these picture elements is generated by the television is given as, first of all we will write the value of the lines, that is 525. It represents the value of lines only. After that we will write the number of picture element, that is 525. So here 525 represents number of picture element. And finally it depends upon the rate of transmission, that is given to us 30 per second. So it denotes the rate. So finally if we solve this, then we will get this value, that is 8268750 elements per second. This is the value of this small r. We will use the value of this small r in the calculation of average rate of information, that is r into h of x. Now let us have a look at the calculation of this h of x, that is entropy. Since we studied that the formula for the entropy is given as summation I equals to 1 to n p of xi log base 2 1 over p of xi. So this is the formula. Now we know that there are 256 levels and which are equiprobable. that are equiprobable. So we can say that the probability of one brightness level will be denoted by P of xi, and it will be equals to 1 over 256, because all the 256 brightness level are equiprobable. Since we know that the h of x specifies the average number of bits of information per message, therefore we can say that these brightness level will be helpful in the calculation of h of x. Now if we put the value in the formula of h of x, then it comes out to be summation I equals to 1 to, in place of this n, here are the 256. So 256, the probability P of xi, whose value is 1 over 256 log base 2, and here 1 over 1 by 256. Now the value of h of x, this whole term will equate to 1 only, because summation I equals to 1 to 256, 1 over 256 will be result into 1 only, and in multiplication with log base 2, this 1 over 1 by 256 will become 256 only. So the final value of h of x will comes out to be 8 bits per element. So this is the value of entropy that we calculated. Now let us have a look at the final calculation, that is the calculation of rate of information transmission, that is calculation of capital R. Since we know that the value of small r is equals to nothing but 8268750 elements per second, and the value of entropy, that is h of x, is equals to 8 bits per element. And we also know that the value of this capital R is equals to R into h of x. So substituting the value of R and h of x, we get the capital R, that is equals to 8268750 in multiplication with 8. So its value will comes out to be 66.15 into 10 to the power 6 bit per second. So this is how we can calculate the average rate of information content that is sent by the TV set towards the viewer. So this is all about this numerical. Let us have a look at one more example that is based on entropy. A discrete source emits one of the 5 symbols in the time interval of every millisecond. Now the symbol probabilities are given to us, that is 1 by 2, 1 by 4, 1 by 8, 1 by 16 and 1 by 16 respectively. What we need to do is we need to calculate the value of h, that is nothing but entropy, and r, that is rate of information. So firstly we will write the data that is given to us. Here the 5 symbols. So let these 5 symbols as S1, S2, S3, S4 and S5. Now their probabilities are given as the probability of symbol S1, that is equals to 1 by 2. Similarly, probability of symbol S2, that is equals to 1 by 4. Probability of symbol S3, that is equals to 1 by 8. Similarly, probability of symbol S4 is 1 by 16 and probability of symbol S5 is 1 by 16. So these are the 5 symbols along with their probability that are given to us. Now let's calculate the value of entropy. So calculation of entropy, that is h of x. Since we know that because here we are taking the symbol that are denoted by s. Since we know that the formula for the entropy is given as summation I equals to 1 to n P of Si log base 2 1 over P of Si. And here we know that here are the 5 symbols, so we can say that the value of n is nothing but 5 only. So the formula for the entropy will be equals to summation I equals to 1 to 5 P of Si log base 2 1 over P of Si. Now expanding this formula, we get h of s, that is equals to P of, in place of I we will firstly write 1, so P of S1 log base 2 1 over P of S1 plus P of S2 log base 2 1 over P of S2 plus P of S3 log base 2 1 over P of S3 plus P of S4 log base 2 1 over P of S4. Similarly, plus P of S5 log base 2 1 over P of S5. So we expanded this formula by writing the value of I from 1 to 5. Now simply substituting the value of the probability that are given to us here, we get the modified expression as h of s, that is equals to, in place of P of S1 we write 1 by 2 log base 2 1 over 1 by 2 plus P of S2 will get replaced by 1 by 4 log base 2 1 over 1 by 4 plus, in place of P of S3 we write 1 by 8 log base 2 1 over 1 by 8 plus, in place of PS4 we write 1 by 16 log base 2 1 over 1 by 16. Similarly, P of S5 will get replaced with 1 by 16 also, log base 2 1 over 1 by 16. Now if we solve this expression, then we get h of s, that is equals to half log base 2 of 2 plus 1 by 4 log base 2 of 4 plus 1 by 8 log base 2 of 8 plus 1 by 16 log base 2 of 16 plus 1 by 16 log base 2 of 16. Now if we write this value of 2, 4, 8 and 16 in the powers of 2, then it can be written as 1 by 2 log base 2 of 2 plus 1 by 4 log base 2 of 2:2 plus 1 by 8 log base 2 of 2:3 plus 1 by 16 log base 2 2:4 plus 1 by 16 log base 2 2:4. Now on solving this whole expression, we get the final value of h of s as h of s equals to 1.875 bits per symbol. So this is the value of entropy that we calculated. So we are done with the value of entropy that we need to calculate, and let's calculate the value of this R, that is rate of information. Now for the calculation of the rate of information, that is R, we know that its formula is small r into h of s. Since we calculated the value of h of s, but we do not have any value of this small r, that is rate of information transmission. So let's have a look at the calculation of this small r. Small r specifies the rate at which the symbols are transmitted by the discrete source. So since we know that the source emits one symbol in every millisecond, this is given in our question. So we can say that for the transmission of 5 symbol, it requires 5 milliseconds. So for transmission of 5 symbols, it requires 5 milliseconds. And we know that the value of small r, that will be equals to total symbols divided by total duration. On substituting the value, we know that here are the 5 symbols. So here we write 5, and we know that for the transmission of 5 symbols, it requires 5 milliseconds. So the total duration will be also 5 milliseconds. So we will get 1 symbol per millisecond, or we can say that it can be written as 10 to the power 3 symbols per second. So this is the value of small r that we are looking for. Now we have the value of this small r, and also we have calculated the value of h of s, that is entropy. So we can easily get the value of rate of information transmission. So let's calculate it. Calculation of capital R. Since capital R is given as the product of small r and h of s, so its value is r equals to, in place of small r we write 10:3 in multiplication with the value of h of s, that is nothing but 1.875. So the final value of r comes out to be 1875 bits per second. So this is the value of capital R. So this is all about this question. If you like my content, then do subscribe my channel and please hit the like button. Thank you.